Okay, welcome back to the classroom. My name is Mr. Wong. Today we're going to be explaining some multiple choice questions of Module 8 in chemistry. So there's about 9 questions in total. As you know, Module 8 is about applying chemical ideas. So let's get on to it and see what the answers are. So in question 1 it says, what is the best way to identify a solution containing barium ions or calcium ions? So as you can see with questions like these are simple recall questions. So it's asking you to recall concepts that you may or may not remember. The answer for this is actually D. So we'll need to do a flame test as barium provides a pale green color and calcium provides a brick red flame. Okay, so there's that. These ones you really just have to know off by heart. Okay, so let's go to question 2. Okay, so question 2 says it is suspected that a stream is contaminated with metal ions. A sample of water from the stream was analyzed. The results of some tests on the sample are recorded in the table. So that's what we have. What is the most likely contaminant in the water? Is it barium, calcium, copper, or iron? So for this question, again, it will look at your understanding of the reactions of dilute acid, your solubility rules, if you remember the different colors, and also the different flame colors. So the answer for this is actually A, barium. So when barium and sulfate combine, it forms the white precipitate barium sulfite. And also in the flame test, barium would give off a pale green color. It should, when it reacts with dilute sulfuric acid, there should be some reaction, so I'm not quite sure why there's no change here. So that's kind of the idea. So answer for question 2 is A. We'll go to question 3. Okay, question 3. It says we have a diagram of a atomic absorption spectrometer. Here we go. So these are all the different components. What is the purpose of the halo cathode lamp? So let's look at our options. Okay, we have A, to produce or to excite the sample, to atomize the sample to produce white light, to produce a light of specific wavelength. Okay, so if we have a look, it can't be to excite or to atomize the example. That's kind of what the flame and the nebulizer is trying to do here. To produce white light, that's not really the idea for it either. We actually want to look at a specific color. So for the halo cathode lamp, we actually use that to produce a specific wavelength of light. Okay, so there's that. We're going to go into question 4. All right, question 4. We have a section of emission spectrum of the mercury lamp shown here. The light is for these particular wavelengths and is passed through a water sample containing mercury, and the intensities were then measured by a detector. You have these two values here. Okay, so the question is, which of the following pairs of intensities can be used in determination of the amount of mercury in water using the atomic absorption spectrum? Okay, so for this question, it might be a little bit tricky, but let's kind of explain through it. Now, the two samples we got were these two wavelengths here, okay? So that's what we have. Now, in order for the atomic mass spectra to work, like we said, the cathode lamp produces a specific wavelength that should excite the metal of interest, okay? So we should produce a light either at 623.4 or 615.2. Okay, so that's the idea. Now, once we produce that light, we also want to know how much of that light was absorbed. Okay, so in order to work out how much light was absorbed, we need to use the same detector that uses the same wavelength that was produced. So in essence, I need to use a light source emitted of 2 or 623 and detector of 623, or a light source of 615 or a detector of 615. So the answer here is A. Okay, let's move on to question 5. All right, in question 5, it says all the lead ions present in a 50 milliliter solution were precipitated by a reaction with excess amounts of chloride ions. The mass of the dry precipitate was 0.595. What was the concentration of lead in the original solution? Okay, so let's just go through how you perform the calculation first. This is the mass of lead chloride. We need to firstly find the number of moles of lead chloride used, and then we can work our way around to find the number of moles of lead and then its mass. Okay, so the mass is that value there. If you look at your formula sheet and work out the molar mass of lead chloride, it should be around this number here. I did take this straight off the internet, so in the actual exam you should use the formula sheet, and that is the number of moles of lead chloride, and that's about it. Okay. If I write the equation for lead chloride and write it into its constituents, we can actually find that lead and lead chloride is a 1-to-1 mole ratio. So it's the same kind of value there. So knowing that, we can actually use that to find the mass of lead, which is the number of moles of lead times its molar mass. It's quite a lot of steps, as you can see. And times by the molar mass, which I found again online to be this value here. And so the overall mass is 0.4428802571 grams. So essentially, if I want to find the concentration in grams per liter, it'll be the mass of the lead divided by our volume, which in this case would be 50 times 10 to the minus 3, and mass would be this number here. You should find that the answer is equal to A. And that's how you do question 5. We move on to question 6. All right, question 6, it says the diagram shows the infrared spectrum of a particular compound. Which compound was analyzed? Was it butane, propanol, propanol, or propanol, or butanoic acid? So you need to grab out your data sheet, which has all the values for the infrared functional groups, and then we'll go from there. All right, so if we have a look at the construction of this chart, remember if we split it off, this on the left hand side, that'll tell us the main functional group that we need to look into. We have a very broad range from about 3,000 onwards to 3,500, so this should tell us a bit of information. If I look at the data sheet, it says that if we have a very broad 32 to 30 to 3,500-ish, that would indicate an alcohol. From the 2,500 to 3,000, if it's very broad, it would indicate an acid. So it's still an OH, but whether or not we get an alcohol or an acid, which in this case, we should get an alcohol because of where the infrared is. Okay, so if it's based on that, then we shouldn't have butane, we shouldn't have propanol, and not butanoic acid. And we should get propanol as our answer. So answer should be B. Okay, so let's move on to the next question, which, if we have a look, is question 7. Okay, question 7, it says a colorimeter was used to calculate the percentage of iron in a 0.2 gram tablet. The tablet was dissolved and oxidized, then we have the following equation following it. The resulting solution was made up to 200 milliliters with distilled water. We have an absorbance of this value here, and we have our curve. So how much iron was in our tablet? So let's try and work that out. Okay, so to do this question, let's look at where the final absorbance is. It's about 0.61, so around about this range here. So if I draw a sort of imaginary line, that should give me a plot of where the theoretical concentration of iron 3 plus is. So about here. So let's say this was about 50 here. We're sort of around 58 micro moles per liter. Okay, so that's kind of our concentration that we have here. It says how much iron, so we're trying to find the mass. So from this concentration, let's work out the number of moles we have. So the number of moles is equal to concentration times volume. Our concentration is 58 10 to the minus 3, because we're trying to convert this into liters. And or not liters, but micro into moles. Actually, that's to the minus 6. And then we have our distilled water solution. We also need to convert that into liters. Plug that in, and that will give you the number of moles. That gives you a number of mole of 0.00000116. Okay, so from there, the next bit we need to do is work out the mass. Now we know that in terms of mass in moles, the mass of the iron 3 plus is the number of moles we have times the molar mass of iron. Okay, so let's just do that. And let's find the molar mass of iron. Okay, so I found the mass of iron again. It's just found it off the net. So try and use your formula sheet to do that. Okay, so that's the mass I have. If I look at the answers, the one closest to that, what I have, is actually this number here. The difference in number could just be round off errors or just the difference in molar mass used. But this is our answer for question 7. Okay, let's move on to question 8. Okay, question 8, it says where phosgene is prepared from the reaction of carbon monoxide and chlorine in the presence of a catalyst. This is an exothermic reaction, as delta H is negative. Which set of conditions would produce the highest yields? So as this reaction is an exothermic reaction, meaning by heat will be produced on this side, if we reduce the amount of heat, so we decrease the amount of heat here, that's going to drive the reaction to the forward side. So we want a low temperature, okay? And the last one is pressure. We actually want a high pressure for this experiment. As you can see, there's actually 2 moles of reactants here and 1 mole of reactant over there. So if it's high pressure, the vessel with more moles of gas will collide more regularly with each other. So the answer we have here is B. So that's question 8. Let's move to question 9, which is also our last question of this section. Okay, question 9, it says the graph represents the yield of an equilibrium reaction Z at different temperature and pressure conditions inside a reaction vessel. So that's what we have here. which reaction could produce the trends shown in the graph here? So I guess what we could work out firstly is it an exothermic or endothermic reaction? Okay. So percentage of Z is our product. Okay, so if that's the case, by increasing temperature, we see a decrease in yield. That would suggest that we have an exothermic reaction because that would drive the reaction back to the left-hand side. So it's either B or D. The last one is pressure. So as you can see, as we increase pressure, the yield increases, which means the number of moles on the left-hand side needs to be greater than the right-hand side, which in this case, D would be the most correct answer. And that concludes our explanation of all the different multiple choices of this sample paper made by Nessa. If you found videos like these useful, give it a like, subscribe, and I'll go on to look at other multiple choice